Hey kids, it's Miss Talent. So we're going to go over our magnetism notes, and what we've done is we're going to break this up into 3 miniature videos. So what we're going to do is we're going to go over magnets, then magnetic field, and then electromagnets. So there'll be 3 separate mini videos, and that way if you're struggling with something in particular, you can go to just that video that correlates with your unit packet or your notes. One thing you'll see on my screen that I need to update you all on is, so this is week 7, so you will complete your notes into your journal, and you will also complete your entire magnetism unit packet, and that needs to be submitted by Sunday the 8th. Then the following week, you're not going to have science. You are actually going to have a bye week where you're doing your iReady mastery tests, and so we will resume the magnetism unit then on May 18th through the 22nd, where you pick the gizmo or one of the do-it-yourself labs. Now, I do know some of you all, it takes a long time to do those mastery tests, and then there's some of you all that it doesn't. So we're flexible, but you do not have to complete any science the week of May 11th through the 15th, and we actually encourage you not to, so you're focused on those 2 mastery tests. So make sure you make those adjustments, that you know that not until the 22nd your do-it-yourself or gizmo is due. So you have a little extra time there. So first we're going to talk about magnets and magnetic material. So I'm going to zoom in. So 13.1, so permanent magnets remain magnetic after multiple uses, and so that means it's always magnetized. There are some magnets after multiple uses, they lose their magnetism, but permanent magnets, and just like it sounds, they remain magnetic and they're permanent. Some magnetic materials that you have come in contact with, those are things that are attracted to a magnet, so like a paper clip, nickel, cobalt, steel, iron. Some of these are elements that you remember from the periodic table. Some of them are alloys that are a combination of elements from the periodic table. So when we did, some of us in regular science, you actually separated salt and iron, and what you used is a magnet, and you were able to pick up the iron filings and leave the salt behind, and so that would be an example of magnetic material. Non-magnetic material is not attracted to a magnet. So for example, aluminum, tin, there's lots of other things that are not attracted, but these are things that are most commonly thought of to be magnetized, which are not. So an aluminum can will not be attracted to a magnet. Okay. Now we're going to talk about, hold on just a second. Sometimes I have to get out of here and then do this. There we go. Okay, now we're going to talk about actual magnetic poles. And a lot of this you probably remember from 5th or 6th grade, but we just need to make sure we understand it. So the magnetic force is caused by 2 magnetic poles being attracted to one another. So a north is going to be labeled as an N, a south pole will be labeled as an S. So, and then the arrows, if they're pointing towards each other, it means they're attracted to one another. If they're pointing away from each other, they're going to repel one another. It's very important to know the 2 rules magnets always follow. Like poles, such as north and north, would repel. Unlike poles, attract. So north and south will attract one another, which means they'll click together. Okay, and I wish we were in class together where you could actually feel the magnets. But for example, I drew them out for you. So north and south would be attracted. South and south will repel. North and north will repel. How do we magnetize a piece of iron? So you actually can stroke the iron with a magnet using the same poles. So when you do that, you can actually magnetize just a simple piece of iron. Now, do you think it will be a permanent magnet? I want you to think about that. If we're actually creating it to be magnetized, will it always be magnetized, or do you think it might lose its magnetism after multiple uses? So think about that. Now, the next video, we're going to break it up once again, will be over magnetic fields.